Hello aspirants, I am going to solve and explain number system problems on divisibility from previous year papers, very useful for exams. Let's discuss the divisibility rules before starting the problems. For 1, every number is divisible by 1. For 2, if the last digit is 0, 2, 4, 6 or 8. For 3, if the sum of digits is divisible by 3. For 4, if the last two digits from a number divisible by 4. For 5, if the number ends in 0 or 5. For 6, if the number is divisible by both 2 and 3. For 7, double the last digit and subtract it from the rest if the result is divisible by 7. If the last 3 digits from a number is divisible by 8, it is 8. For 9, if the sum of digits is divisible by 9. For 10, if the number ends in 0. For 11, if the alternating sum of digits is divisible by 11. For 12, if the number is divisible by both 3 and 4. For 13, multiply the last digit by 9 and subtract it from the rest if the result is divisible by 13. For 14, if the number is divisible by both 2 and 7. For 15, if the number is divisible by both 3 and 5. Let's check into the problems. Which of the following numbers is divisible completely by both 9 and 11? We know that for 9, the sum of digits of a number is divisible by 9. Let's check the option B, 10098. Its sum is 1 plus 0 plus 0 plus 9 plus 8, which is equal to 18. 18 is divisible by 9. So, 9 follows. And the next one is 11. For 11, the sum of alternative digits means the sum of even digits minus sum of odd digits should be divisible by 11, or for 11, the sum of even digits minus sum of odd digits is equal to 0 or multiple of 11. It means nine plus 0 minus 8 plus 0 plus 1, which is equal to 9 minus 9, that is equal to 0. So 11 also follows. So option B is correct. And coming to the second question, which of the following numbers is not divisible by 9? Let's check with all the options. We know that divisibility rule of 9 is the sum of all the digits is divisible by 9. For 49140, the sum is 4 plus 9 plus 1 plus 4 plus 0. It is 18. So it is divisible by 9. It follows. And second one is 7 plus 7 plus 8 plus 3 plus 2, which is equal to 27, and it is also divisible by 9. And third one is 3 plus 5 plus 2 plus 5 plus 3, which is equal to 18, and it is also divisible by 9. And fourth option is 4 plus 5 plus 3 plus 9 plus 0, which is equal to 21. 21 is not divisible by 9. So, the option D is correct. Which of the following number is not divisible by 8? If the last 3 digits of a number is divisible by 8, then the number is also completely divisible by 8. Let's check with the options. In this, last 3 digits are 792. Let's check whether it is divisible by 8. It is equal to 99. So it is divisible. And here 112 divided by 8, which is equal to 14. So it is also divisible. And here 412 divided by 8, which is 51.5, which is not completely divisible. So option C is correct. If the 7-digit number 5045x53 is divisible by 11, then the one of the values of sum of x and y is question mark. Given the number is 504x 5y3. According to the question, the number is divisible by 11. We know the divisibility rule of 11 is if the difference of sum of digits at even place and at odd place is 0 or completely divisible by 11. Let's check with that. The sum of even places are 0 plus x plus y, and the sum of odd places are 5 plus 4 plus 5 plus 3, which is equal to 0, and x plus y minus 17 is equal to 0, and x plus y is equal to 17. So the sum of x and y is 17. Option C is correct. If the 9-digit number 88P554085K6 is divisible by 72, then what is the value of 3K plus 2P? (72) means it should be divisible by both 8 and 9. Let's check with 8 first. Divisibility rule of 8 is last 3 digits should be divisible by 8. Here last 3 digits are 5K6. (5K6) divided by 8. Let K equal to 3. Then 536 divided by 8, which is equal to 67. So completely divisible by 8. And coming to 9. Divisibility rule of 9 is the sum of all digits in a given number should be divisible by 9. Let's do it. 8 plus 8 plus. Here, before we have taken k equal to 3. Let p equal to 2 here. Means 2 plus 5 plus 5 plus 4 plus 0 plus 8 plus 5 plus 3 plus 6 divisible by 9, which is equal to 54 by 9, that is equal to 6. So this is also divisible by 9. Now we have to find the value of 3k plus 2p, that is equal to 3 into 3 plus 2 into 2, that is equal to 13. Option A is correct. When a number n is divided by 5, the remainder is 2. When n square is divided by 5, the remainder will be. We know that number is equal to divisor into quotient plus remainder. According to the question, n is equal to 5 into q plus 2. Squaring on both sides. That implies n square is equal to 25q square plus 4 plus 20q, a plus b whole square. Let's divide equation 1 with 5. Means n by 5, n square by 5 is equal to 5q square plus 4 by 5 plus 4q. From this, the required remainder is clearly 4. How many numbers of first 100 positive integers are divisible by 3 or 4 without a remainder? The total number of positive integers given is 100 divided by 3 is equal to 33, and for 4, 100 divided by 4, that is equal to 25. The total number of positive integers divisible by 12 is equal to 8. Therefore, total is equal to 33 plus 25 minus 8, which is equal to 50. Option A. We have solved the similar type of questions above, so it is homework for you, and this one also homework. Comment the answers in comment section. Which of the following is the greatest 3-digit number that is divisible by 13? We know that greatest 3-digit number is 999. When 999 divided by 13, it is equal to 76 11 by 13. Leaves remainder 11. So greatest 3-digit number divisible by 13 is equal to 999 minus 11, which is equal to 988. So option C is the answer. Here we are just subtracting the greatest 3-digit number with the remainder when divisible by 13 to obtain the answer. The number 93248x6 is divisible by 11, then the digit x is equal to question mark. We know the divisibility rule of 11 is sum of even places minus sum of odd places is equal to 0. So 9 plus 2 plus 8 plus 6 minus 3 plus 4 plus x. It implies here for 11 it could be 0 or multiple of 11. Let's take 11 here. So 25 minus 7 plus x is equal to 11. 18 minus x is equal to 11, and x equal to 18 minus 11, that is equal to 7, which is option D. 41 power 43 plus 43 power 43 is divisible by, if x power n plus a power n is divisible by x plus a, then the value of n is odd. Here 43 is odd number. Therefore, 41 power 43 plus 43 power 43 will be divisible by 41 plus 43, that is equal to 84, which is option D. This is X and this is A. If PQ is a two-digit number, then PQ minus QP will be divisible by let the two-digit number PQ is equal to 10x plus y. Then QP is equal to 10y plus x. According to the question, PQ minus QP, that is equal to 10x plus y minus 10y plus x, that is equal to 10x plus y minus 10y minus x, that is equal to 9x minus 9y, which is equal to 9 of x minus y. It means it is divisible by 9, which is option A. If a positive number n when divided by 5 leaves a remainder 3, then the units place digit of n is question mark. Required number is equal to 5k plus 3. Since k equal to 0, 1, 2 and so on. Let's start with 0. 5 into 0 plus 3, that is equal to 3. Let's start with k equal to 1. 5 into 1 plus 3, that is equal to 8. Let's take k equal to 16. 5 into 60 plus 3, that is equal to 303. Let's take k equal to 61. 5 into 61 plus 3, that is equal to 308. So the unit digit of n is 3 or 8. If a number when divided by 7 leaves remainder 4, then what will be the remainder when square of the same number is divided by 7? According to the question, number is equal to divisor into quotient plus remainder. So that is equal to 7 into n plus 4. Let n equal to 1. That implies number is equal to 7 into 1 plus 4, that is equal to 11. On dividing by 7, the remainder is 4 according to them. Let's divide the square of 11 by 7, which is 121 by 7, that is equal to remainder is equal to 2, which is option C. The smallest positive number which must be added to the greatest number of 4 digits in order that the sum may be exactly divisible by 307 is the greatest 4-digit number is 9999. When divided by 307, 3073 is 921, which gives 78, and 9 when divided by 2, it gives 614, and the remainder is 175. Therefore, smallest number to be added is equal to 307 minus 175, which is 132. Option B. How many numbers between 1 and 700 are completely divisible by 17? The numbers between 1 and 700 exactly divisible by 17 are 17, 34, and so on, 697. We know that L is equal to A plus N minus 1 into D. The last term is 697 and the first term is 17 plus number of terms n minus 1 into difference is 17. That implies 680 is equal to 9 minus 1 into 17. 40 is equal to 9 minus 1. 40 is equal to n minus 1 and n is equal to 41. So the required number is 41. What is the total number of odd and even divisors of 120 respectively? Odd and even divisors of 130 means all divisors of 130, that implies 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60 and 120. Here the number of odd divisors is equal to 4 and number of even divisors is equal to 12, which is option number C. What is the greatest number of 5 digits which is exactly divisible by 468? The greatest number of 5 digits is 99,999. When divided by 468, let's take 3 terms here. 468 twos, 936, and left over is 63, and take 9, and 468 ones, 468, which is 171, and take the leftover 9, and 468 threes, 1404, and the remainder is 315. So required number is equal to 99,999 minus 315, which is equal to 99,684. Option B. In between 250 to 1000, how many numbers are completely divisible by 5, 6 and 7? Let's take the LCM of 5, 6 and 7. It is equal to 210. Numbers from 250 to 1000 which are divisible by 5, 6 and 7 will always divisible by 210. Divisible by 5, 6, 7 will always be divisible by 210 or multiple of 210. Therefore, 210 into 1, 210 into 2, 210 into 3, 210 into 4, 210 into 5 and so on, which is equal to 210, 420, 630, 840 and so on. Here they have asked between 250 to 1000. So it is 1, 2, 3. Only 3 numbers are completely divisible by 5, 6 and 7. The largest 4-digit number that is exactly divisible by 83 is, the largest 4-digit number is 9999. When divided by 83, it gives 39 as remainder. Therefore, required number is equal to 9999 minus 39, which is equal to 9960, which is option D. (47 whole power 25 minus 1 is exactly divisible by 47 power 25 minus 1 power 25. It is in the form of a power n minus b power n, which is completely divisible by a minus b. So, 47 minus 1, that is equal to 46, which is equal to 2 into 23. So, option C is 23. If 1, 1, 1 and so on 1 n digits is divisible by 9, then the least value of n is divisibility rule of 9 is sum of all digits in given number is divided by 9. For 1, 1, 1 and so on 1, let n equal to 1, which is not divided by 9. Let's take n is equal to 2. Then the number is 11. 11 is not divided by 9. Let's take n equal to 3. Then it is 111. That is 1 plus 1 plus 1, that is equal to 3, not divided by 9. And so on. Let's take n is equal to 9. Means 1, 1, 1, 1, 1, 1, 1, 1, 1. 1 plus 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 1. That is equal to 9, which is divisible by 9. So the least possible value of n is 9, option C. A number, when divided by 280, leaves 73 as remainder. When the same number is divided by 35, then the remainder will be. Let number is equal to n. Then n is equal to 280k plus 73. It can also be written as 35 into 8k plus 73, which further implies 35 into 8k plus 70 plus 3, that is equal to 35 into 8k plus 2 plus 3. Let 8k plus 2 is equal to m. That implies n is equal to 35m plus 3, which is equation 1. On dividing the same number by 35, when we divide the same number by 35, the remainder is 3, which is option C. What is the smallest number that is exactly divisible by 2, 3, 4, 5, 6, 7, 8, 9 and 10? Let's take LCM. LCM of 2, 3, 4, 5, 6, 7, 8, 9 and 10 is equal to 2520. So the smallest number is 2520, which is exactly divisible by 2, 3, 4, 5, 6, 7, 8, 9 and 10. How many numbers greater than 2 and less than 30 are divisible by 1 and themselves only. Divisible by 1 and themselves means prime number. Prime numbers between 2 to 30 are 3, 5, 7, 11, 13, 17, 19, 23 and 29. Total 9 numbers. Option A. 3 power 71 plus 3 power 72 plus 3 power 73 plus 3 power 74 plus 3 power 75 is divisible by. Let's simplify it as 3 power 71 into 3 power 0, which is equal to 1, plus 3 power 1 plus 3 power 2 plus 3 power 3 plus 3 power 4. Since a power m into a power n is equal to a power m plus n, that is equal to 3 power 71 into 121. 3 power 71 into 11 square. So the given series is divisible by 11. The smallest 5-digit number that leaves a remainder 6 when divided by 7 is. The smallest 5-digit number is 10,000. When divided by 7, remainder is equal to 4. Therefore, required number is equal to 10,000 plus their given remainder 6 minus 4, which is equal to 10,002. Option B. N is a whole number which when divided by 6 leaves a remainder 4. Find the remainder when 2n is divided by 6. According to them, n is equal to 6a plus 4. Multiply the number n with 2, that implies 2n is equal to 2 into 6a plus 8. 2n is equal to 12a plus 6 plus 2. 2n is equal to 6 into 2a plus 1 plus 2. Hence, the remainder is 2. Option B. Find the least 6-digit number that is a multiple of 18. The least 6-digit number is 1 lakh. Let's divide it with 18. 18 5s 90. Hence, remainder is 10. So, 18 minus 10, that is equal to 8, plus 1 lakh, which is equal to 1 lakh 8. What number should be deducted from 1265 to make it divisible by 29 exactly? 1265 divided by 29. So, 18 should be deducted from 1265 to make it exactly divisible by 29. Find the least number to be added to 1739 to make it exactly divisible by 11. 1739 when divided by 11 gives therefore required number is equal to find the remainder when 3 power 7 is divided by 7. 3 power 10 is equal to 3 into 3 into 3 into 3 for 10 times. And 3 power 10 value is 59,049. When divided by 7 means 59,049 divided by 7, which gives remainder as 4, which is option A.